AP Review 5. I'm interested to see if they give us multiple choice on this year's AP exam. I'm sure in subsequent years they'll be giving it again, but this is a special year, so I'm interested to see what happens. Let's take a look at these problems. We start with problem number 1. And problem number 1, that's very interesting. Huh. A mischief maker has made off with one of my pages. Yes, they have. All right. So let's hope that I get these right the first time. All right. AP Review, multiple choice 5. No calculator allowed for these. Problem 1, and they tell us 55 minutes. You might want to set a timer here to make sure that you go through this in 55 minutes. We're told that f is x squared ln of x. We want to find f prime of x. This is product rule. So we should be okay with that. And that looks like 2x ln of x plus these cancel, leaving the x, and that's e. Number 2, we've got the integral from 3 to 11 of 1 over square root 2x plus 3 dx. I'm going to say that u equals 2x plus 3. Du over 2 equals dx. So then this becomes the integral of u to the minus 1/2 du over 2. And what about some u-bounds? If I plug a 3 in here, I get 9, and if I plug an 11 in here, I get 25. So I've got 1/2 the integral 9 to 25 of u to the minus 1/2. Well, the antiderivative of this means I have to add 1 here, so I've got u to the 1/2. Why, look, there was a 1/2. How convenient. So that 1/2 comes down, and there it is. And so really, I just need to evaluate this between 9 and 25. And so I get 5 minus 3, or 2. And that's choice B. B for number 2. Let's take a look at problem number 3. Problem number 3 says the limit as x approaches c of f of x equals f of c for all values. So they're telling me here that the f is continuous on 0 to 5. They're telling me that f of 0 does not equal f of 5. Which of the following statements could be false? Well, if this function is continuous because of this statement here, the limit as x approaches c of f equals f of c. F is continuous on 0 to 5 is what I take from that. Therefore, f is continuous on 0 to 5. F of 4 exists. Yes, that's true. A. F prime of 1 exists. Well, just because the function is continuous doesn't mean it's differentiable. C, the limit as x approaches 2 must exist. Yes, that's part of continuity. We couldn't be continuous unless that limit existed from the positive side. So C is true. D, the limit as x approaches 3 from the negative is equal to the limit as x approaches 3 from the positive. That's what we need in order for the limit as x approaches 3 to exist. And since the function is everywhere continuous, we know that the limit as x approaches 3 must exist. Therefore, D is also true. And then we're told that the limit as we approach from the positive side of 0 and from the negative side of 5 are not equal, and we can know that because of the statement that says f of 0 does not equal f of 5. So I know that E is also true, so B is my answer to number 3. B is number 3. 4, we've got the limit as x heads to 0 from the positive of 12 over 4 plus e to the cosecant x. Okay, so if I plug in a 0 here, cosecant of 0, that's infinity. Think about that cosecant graph for a second. Here's sine. Here's vertical asymptotes. And here's cosecant. So as we approach 0 from the positive side, this thing's heading up towards infinity. E to the infinity is infinity, plus 4 more. I've got infinity. 12 divided by infinity. 12 divided by 12 pizzas, an infinite number of people come to dinner. You're not getting any pizza. And so that answer is B as well. Okay, 5. Which of the following differential equations corresponds to the slope field shown above? The slope field shown above. Well, I see for y equal to 0, I have a 0 slope. So y equals 0 gives me a 0 slope. That's true in A, B, and C, but not true in D and E. So I've eliminated 2 of the choices. I also notice that at x equals 0, I have a 0 slope. And so that eliminates choices B and C, and therefore only A would have x equals 0 and y equals 0, dy dx equals 0. So choice A for number 5. Okay, 6. They want us to take the derivative of 2 to the cosine x. Okay, so we take the derivative of 2 raised to the power of, we get 2 to the power of, don't forget ln of 2, times the derivative of that inside function, which is minus sine x. So I've got minus sine, or minus sine ln 2, that's choice C. Choice C for number 6. 7. Integral e to the minus x plus e to the 2x over e to the x dx. You know, I recommend using some algebra here and rewriting this like this, because then you could take that a little further and say, when I'm dividing and the bases are the same, I subtract the exponents inside the integral of e to the minus 2x, and here I subtract the exponents plus e to the x dx. Okay, the antiderivative here is going to be e to the minus 2x over negative 2, plus the antiderivative here is e to the x. Don't forget the plus c. If you're not sure how I did this, do a u substitution with u equal to negative 2x, and that should get you there. I've got choice D here. Choice D. Okay, 8. 8 says f prime equals x to the third, x plus 2 squared. Then the graph of f has inflection points, so I'm looking for maxes and mins on f prime, q, or f double prime equal to 0. Okay, so let's find f double prime. F double prime, 3x squared, x plus 2 squared, plus x to the third times 2, x plus 2 to the first times 1. Okay, I notice that I can factor out an x squared and an x plus 2. So x squared, x plus 2. I'll be left with a 3, an x plus 2, a plus sign, one of these 3 x's, and 2. And if I combine my terms, I get 5x plus 6, x plus 2, and x squared. So that's f double prime. Inflection points. Okay, so I've got these critical points at 0, at negative 2, negative 6/5, and 0. but there's a bounce here. So I'm not, I'm going up on this end and bouncing here. No sign change here, only sign changes at these points. So these are where I have my inflection points on F, and that corresponds to choice D. Choice D. Watch out for this. Many people say x equals 0. X equals 0 is a critical point, but it's not an inflection point because I don't have a sign change there. Okay, problem number 9. We've got F is given as the integral from 2 to sine x square root of 1 plus t squared dt, and they want f prime. Oh, so this is FTC part 1. Take the derivative of this integral. We have our constant down here like we want. So this is just going to jump in there. Square root of 1 plus sine squared x times the derivative of that inside function, cosine x. So this is 1 plus sine squared x to the 1/2 times a cosine x. That looks like choice D. Choice D for number 9. Okay. Number 10. 10 says, let f be a continuous function shown in the picture above. The area of the region bounded by f, the x-axis, and x equals a equals 5. Okay, so I know that this area is 5. If the integral from a to b of f equals 3, and that's 0, and that's a, and they ask me what's the value of the integral from 0 to b of f. Well, I know that the integral from a to b of f would equal the integral from a to 0 of f plus the integral from 0 to b of f. I'm trying to find this one, so I want to subtract this one from that one. So 3 minus 5 equals -2. I get -2, and that's choice B. I'm taking the integral from a to b, which is 3, and I'm subtracting from it the integral from a to 0, which is 5. 3 minus 5 is -2, and that corresponds with choice B for number 10. Number 11. The limit as x heads to infinity of 2x plus 3 over square root x squared plus x plus 1. Okay, so, I could do this a bunch of different ways. Plugging in infinities, I see infinity over infinity, and so I'm tempted to use L'Hopital's rule, but this is multiple choice, and no one's going to know if I say this stuff doesn't matter. Square root of x squared is x. 2x over x is 2, and so I say 2 is my answer there. Go speed. Okay, 12, and that's D. 12, the solution to the differential equation, dy dx equals x over cosine y, with the initial condition y of 1 equals 0. So we've got cosine y dy equals x dx. We integrate both sides. We get sine y equals x squared over 2 plus c. I'm going to evaluate for c now before I do the inverse sign of both sides. I'm going to plug in a 1 for x and a 0 for y. The sine of 0 is 1 squared over 2 plus c. 0 equals 1/2 plus c, so c equals -1/2. And so I can then rewrite this as sine of y equals x squared minus 1 over 2, and y equals sine inverse x squared minus 1 over 2. Sine inverse x squared minus 1 over 2, that's choice A. Choice A for number 12. 13. Let's take a look at 13. 13 says, for x greater than 0, the derivative with respect to x of inverse sine of ln of x is what? Okay, so I need the derivative of inverse sine. That's 1 over square root of 1 minus x squared, squared x, times the derivative of that inside function, 1 over x. Okay, 1 minus 1 minus ln squared times x. That's choice D. Don't forget your derivatives and your integrals. 14. You should be working on that integration and differentiation packet. G is given by 3x squared over e to the 3x. Where is G increasing? G increasing when G prime greater than 0. So let's find G prime with the quotient rule, low D high minus high D low over low squared. Okay, I can factor in e to the 3x out of the top, an x and a 3, 3x e to the 3x. What's left over is this 2 minus, I took out a 3, I took out an e to 3x, I took out an x, minus 3x over e to the 3x times e to the 3x. Doink. Okay, so when is this equal to 0? Well, when x equals 0 and when x equals 2/3. Okay, this is always positive, so I only need to check values up here. If I plug in a -1, this will be negative. -1 times -2, this will be positive. Negative times positive is negative, divided by positive is negative. If I plug in a 1/2 here, this is positive, this is positive, this is positive, so this is positive. And if I plug in a 1 here, this is negative, this is positive, so the top is negative, the bottom is always positive, and I get negative. So G is increasing on 0 to 2/3, and 0 to 2/3 is choice C. Choice C for number 14. Okay, now we skip to 15. There we go. 15. Don't flip the page over, Mr. Euclid. You're not done yet. 15. I've got x squared y plus y squared plus 4 equals 0. When x equals 2, the value of dy dx is what? So I need to take the derivative of this. 2x times y plus x squared. Now I want the derivative of this with respect to x. Plus, chain rule here, right? I take the derivative of the outside, I leave the inside alone. And then I take the derivative of the inside, that's that y thing on the inside, with respect to x. The derivative of 4 is 0, and the derivative of 0 is 0. So, what's the value of dy dx when x equals 2? But wait a minute, I need a y value here. Well, let's think about this for a second. I have this original relationship given as x squared y plus y squared plus 4 equals 0. If I plug my 2 in here, I get 4y plus y squared plus 4 equals 0. That gives me y plus 4y plus 4, which factors as y plus 2, y plus 2, and so I know that y equals negative 2. So now I've got a y value and an x value. I can go back to this derivative, and I can plug in 2, negative 2, plus 2 squared dy dx, plus 2 times negative 2 dy dx equals 0. And this is very interesting because this is going to be 4 dy dx, this is going to be negative 4 dy dx, and when I combine those, I end up with negative 8 equals 0. Wait a minute, negative 8 doesn't equal 0. So what I know is this derivative does not exist at x equals 2. Non-existent. This is not possible. Okay. Problem number 16. The slope of the tangent line y equals tan 2x at x equals pi over 8. Okay, so in order to find the slope of the tangent, I need... It's very interesting that they said tangent line to the graph of tangent. I need the slope, so I need y prime, which is secant squared 2x times, don't forget the derivative of the inside, 2. So there's my y prime at pi over 8. So I need secant squared 2 times pi over 8 times 2. Well, that's pi over 4, and I don't know secant of pi over 4, but I know cosine of pi over 4 is root 2 over 2, and secant of pi over 4 must be the reciprocal of that, and if I rationalize, I end up with root 2. The secant of pi over 4 is root 2, but I want secant squared. I want root 2 squared times 2, so I get 4. 16 is 4, and that's choice E. Okay, 17. 17 says the area enclosed by y equals 5 minus x squared and y equals 1. Well, let's think about this graph. Here's 5 minus x squared. Here's y equals 1. And we're thinking about this area. Well, I want to go from here to here. Well, I don't know where these x values are. And that's going to be a problem when I want to integrate top minus bottom, 5 minus x squared minus 1, or 4 minus x squared dx, from where to where. So let's take this y value and replace y with 1. 1 equals 5 minus x squared equals 4, x equals plus or minus 2. So I can do from negative 2 to 2, or to save time and reduce the amount of sign mistakes I make, SIGN mistakes, because of symmetry here, I can do 2 times 0 to 2 of 4 minus x squared dx. The antiderivative here is 4x minus x to the third over 3 over 3, yes, from 0 to 2, and don't forget to double that. So if I plug in my 2, I get 8 minus 8 thirds. This is 24 thirds minus 8 thirds is 16 thirds times 2 is 32 thirds. And 32 thirds corresponds with E, our third E in a row. Okay, problem number 18, find the average value. Well, average value on 0 to 4 of e to the 3x dx. So I need the antiderivative of that. That's e to the 3x over 3 times 1 over 4 from 0 to 4. That's going to be 1/12 e to the 12 minus e to the 0. E to the 0 is 1, and so I get 1/12 e to the 12th minus 1. 1/12 e to the 12th minus 1 is choice A. Choice A for number 18. 19. The region enclosed by the graph y equals square root of x minus 1 and x equals 4. X-axis revolved, volume of the solid generated. So we've just got a bunch of circular disks here. So we're integrating pi r squared dx from 1 to 4. That's going to be the same as pi 1 to 4 of y squared dx. And our y value is square root of x minus 1. And so we've got pi 1 to 4 square root of x minus 1 squared dx. This is a pretty gentle integral for us to consider, x minus 1 dx from 1 to 4. So we're going to have x squared over 2 minus x from 1 to 4. Okay, so I get 16 divided by 2 is 8 minus 4 minus, I plug in a 1 half minus 1, and don't forget there's a pi out in front. So this is 4, this is minus 1 half, minus a minus 1 half is plus 1 half, so 4.5 pi or 9 pi over 2. 9 pi over 2 corresponds with choice D. Okay, problem number 20. 20. X squared minus, I wish my eyes worked, equals 5. Find the second derivative at 3, 2. Okay, so the first derivative is 2x minus 2y dy dx equals 0, or 2x divided by 2y equals dy dx. And so there's the first derivative. But I need the second derivative, so I need to take the derivative of this, which means I need to use quotient rule. Low d high minus high d low over low squared. And I'm supposed to plug dy dx in here. And so I've got y minus x times x over y squared. So let's plug in our ordered pair now. So we've got 2, and watch out, because many people put the 3 in here. It's very, very interesting what our brains do. This is a y value, so I put the y value in there, minus 3 squared over 2 over 2 squared. So this is 9 halves, this is 4 halves minus 9 halves is negative 5 halves divided by 4 over 1, which is negative 5 eighths. Negative 5 eighths is choice D. Choice D for number 20. Let's take a look at 21. The velocity of the particle is given by t to the third minus sine t plus 2. When is the acceleration at 2 pi? So we know that a equals dv dt, so we need to take the derivative of this 3t squared minus cosine t, derivative of that is 0. And we want to evaluate acceleration at 2 pi. So that's 3 times 2 pi squared minus cosine of 2 pi. Cosine of 2 pi is 1. 2 squared is 4, so 4 times 3 is 12 pi squared minus 1. 12 pi squared minus 1. There it is, choice C. Took me a minute to find that. Okay, 22. 22 says the integral from 0 to the square root of e minus 1. Is that really e minus 1? It sure is e minus 1 of x over x squared plus 1 dx. You know, it kind of looks like inverse tan, except, remember, I see the derivative of this up here. And inverse tan, this would have to be a constant. It is not a constant. So u equals x squared plus 1, du over 2 equals x dx. So this becomes the integral of 1 over u du over 2. Now what about some bounds? If I plug a 0 in here, I get 1. And if I plug the square root of e minus 1 in here, the square root of e minus 1 squared is e minus 1 plus 1 is e. And so I've got 1 half ln of u from 1 to e, which is 1 half ln of e minus ln of 1. You can't leave your answer like this, and luckily in multiple choice they just give us things. Oh no, they do that. That's there, but no, they now. Ooh, look at choice B. That's terrible algebra. Ln of e is 1. Ln of 1 is 0. So I've got 1 times 1 half, which is 1 half, or choice C. Choice C for number 22. How about 23? 23. F prime equals 10x on negative pi over 2 to pi over 2. F of pi over 3 equals ln of 6. What's f of pi over 4? Well, you know, the way I think about this is they've given me a derivative function and they've given me these two antiderivative points. I think f of pi over 4 minus, ooh, I should take the smaller one second, pi over 3 minus f of pi over 4 equals the integral from pi over 4 to pi over 3 of 10x dx. Okay, and what do we know? We know this one is ln of 6 minus f of pi over 4 equals this integral. You may recall this was the very first u sub we did. We rewrote this as sine x over cosine x, and we said that u would be that denominator cosine x, and minus du would equal sine x dx. So this is negative 1 over u du, or negative ln of u. Negative ln of u. And what about some u bounds? If I plug a pi over 4 in here, I get root 2 over 2. And if I plug in a pi over 3 here, cosine of pi over 3 is 1 half. So this is going to be 6 minus f of pi over 4 equals negative ln of 1 half minus negative ln of root 2 over 2. Okay, so then be careful. F of pi over 4 equals ln root 2 over 2. This is a positive minus ln of 1 half. Hey, and remember, we can combine two lives joined with subtraction into one live joined with division. Ln of root 2 over 2 over 1 half, which is ln of root 2. Okay, so now I've got ln of 6 minus f of pi over 4 equals ln of root 2. And so I want to say that's going to be ln of 6 minus ln of root 2 equals f of pi over 4. However, I don't see that answer there. So that means I need to do some more stuff with this. Square root of 2 is 2 to the 1 half, and I can pull that 1 half power out in front. In fact, I'm not going to pull that. I'm going to just combine these into one log. Ln of 6 over 2 to the 1 half, or square root of 2. And then I'm going to rationalize. Lots of algebra in this one. Ln of 6 root 2 over 2, which is ln of 3 root 2. And ln of 3 root 2 is choice C. Wow, that was a lot of algebra. I hope you know your log properties. Okay, or skip 23 and move on and save the time. 24. 24, what is the value of x if the line tangent to y equals x squared is parallel to y equals square root of x? Parallel. So parallel lines have the same slope, so we want to know when y prime here equals y prime here. X to the minus 1/2 or 1 over 2 root x. So I want to set this derivative equal to this derivative. So 2x equals 1 over 2 root x. And I'm going to multiply both sides by root x. And I'm going to divide both sides by 2. So I'm going to have x root x equals 1 over 4. This, by the way, is the same as x times x to the 1/2, which is x to the 3/2 equals 1/4. So to solve for x, I raise both sides to the 2/3 power, and I get x equals, I don't know the cube root of 4. Well, I know that this is 2 squared. And that would be 2 to the negative 2 to the 2/3, which would be 2 to the negative 4/3 equals x. 2 to the negative 4/3. Oh, of course that's not there. Damn. What is there? Let's go back to, I need something with a cube root. Do I have something with a cube root? I've got some things with cube roots. Okay, so then x equals 1 over 4 to the 2/3 power. Okay, that's 1 over 4 times 4 under a cube root. So I need 3 of a kind. I'll rationalize with a cube root of 4. And that's going to give me, I'm going to come over here, cube root of 4 on top and 4 on the bottom. Cube root of 4 over 4 is choice B. Again, a lot of algebra there. Very simple calculus, find the derivatives, set them equal, and then a whole bunch of algebra for us to do. I don't think they're going to do much of that on the COVID-19 year multiple choice problems. 25. The function f is ln of x over x. For x greater than 0, f is decreasing on what interval? So I need to find f prime less than 0. That means I need to take the derivative, which is going to be low d high minus high d low over low squared. So I've got 1 minus ln of x over x squared. This derivative is undefined at x equals 0, but that's okay. They told me x is greater than 0. This derivative equals 0 when 1 minus ln of x equals 0, which is when 1 equals ln of x, or when x equals e. So if I put x equals e here, and I go back to my f prime, and I try some values like 1 and e squared, if I plug in a 1, ln of 1 is 0, I get 1 over 1, which is positive. And if I plug in e squared, I can bring that 2 down and have 2 ln of e. ln of e is 1, 2 times 1 is 2, 1 minus 2 is negative 1 over a positive, and so this is negative over here. So I'm asked to find out when f is decreasing, and f is decreasing from e to infinity, and that is choice E. E for number 25. E for number 25. Okay. Oops. E for number 25, and we have B for number 24. 26. 26 says the limit as x approaches 2 of e to the, really wish my eyes were, e to the 2x minus e to the 4th over x minus 2. If I plug in a 2, I get e to the 4th minus e to the 4th, which is 0, over 2 minus 2, which is 0. So I need to use L'Hopital's rule here. I don't have to worry about writing a justification because this is multiple choice. The derivative up top is 2. Oh, don't forget the limit. The limit as x approaches 2 of 2 e to the 2x, and the derivative on the bottom is 1. If I plug in my 2 now, I get 2 e to the 4th. 2 e to the 4th is choice E. Choice E for number 26. 27. Okay, 27 is the integral from 0 to pi. I think that's pi squared. Pi squared over 9. And I've got 1 over square root of x cosine squared square root of x dx. You know, when I look at this, I see 1 over root x times secant squared root x dx. And this is a u sub, where u is square root of x, and du would be 1 over root x dx. That's right there. So this then becomes the integral of secant squared u du. So what about some u-bounds? Well, if I plug in a 0 here, I get 0. If I plug in a pi squared over 9, square root of pi squared over 9 is pi over 3. So secant of pi over 3, I don't know, but I know that the cosine of pi over 3 is 1/2. And so the secant of pi over 3 would be 2 over 1. But I want secant, oh, no, no, no. Bad. Don't forget to do the antiderivative. The antiderivative then would be tangent pi over 3 minus tangent 0. Okay, so tangent of pi over 3 is the sine of pi over 3 over the cosine of pi over 3 minus tangent of 0 is 0. So I get root 3 as my answer to number 27. And that's choice D. Choice D for 27. And 28, the last problem in this section before we start the calculator component. The last problem in this section says f is continuous, differentiable. The table above shows certain values of x. Function f must have 1 point of inflection, 1 relative min, 1 point of inflection, 2 maxima, 1, 0, 2 inflection points. Wow, there's a whole lot of stuff here. Well, from the intermediate value theorem, I see I go from a positive to a negative, and since this function is continuous, I know that there's a 0. So there's 1, 0. I see that this function is decreasing and then increasing, decreasing and then increasing, but look, then decreasing again. So I have 2 extremo, 1 max, 1 min. And what about inflection points? Well, I was decreasing, increasing, decreasing. I could say 1 inflection point. So 1 IP, 1 max, 1 min, 1, 0. Let's look for that. 2 points of inflection, no. 2 zeros, no. 1, 0, 2 points of inflection, no. 1 point of inflection and 2 relative maxima for all real values of x, no. 1 point of inflection and 1 relative minimum, yes. A. A is the choice for number 28. Okay, great. Now the calculator portion. let's take out our calculators. And oh, by the way, we were supposed to do that in 55 minutes. I did it in 45, so you can go a little slower on your own, but not a whole lot slower, huh? Okay, so 29. 29. Where's my calculator? There's my calculator. What's the area of the region in first quadrant enclosed by the graphs y equals 2 minus x squared, which is the same as negative x squared plus 2, and y equals 3 sine x? Okay, so let's graph those. Y equals 2 minus x squared and 3 sine x. And I have no idea, so I'm doing zoom standard. And I see my downturn parabola. And I want the area enclosed by the two curves and the y-axis. So I just want this little portion here. So how about 0 to 1, or 0 to pi over 2, and 0 to, yeah, I'm going to go with 2. Let's see what we see. There's our region right there. We want to find the area of that region. And the area of that region is going to be the integral of top, which is the parabola, 2 minus x squared, minus bottom, 3 sine x dx, from a to b. A is 0, b is the point of intersection, which I need to find with my calculator. Second, calculate intersect. Yes. And I get 0.585325. Okay, so let's do this integral. Math integral of 2 minus x squared minus 3 sine x, comma x, comma 0, comma 0.5853205. And I end up with 0.604. 0.604 is choice B. Choice B for number 29. 30. Let's take a look at 30. Let f and g be differential functions. G is not equal to 0. H is f over g. Oh, thank you so much for finding the derivative of h for me, so I don't have to. But is that really the derivative? Wait a second. I thought the quotient rule, f over g, should be low d high minus high d low, g prime, over low squared. And I see they're telling me h prime equals f times g minus g prime over g squared. Well, I see the g minus g prime, and they have factored out an f, which means that f must be equal to f prime. So what function has its own derivative? Well, that's a e to the x. Okay, 31. Base of the solid in first quadrant bounded by the curve y equals 3 minus x, e to the negative x. Cross sections perpendicular to the x-axis are squares. What's the volume of the solid? Okay, so we've got this, 3, 3, perpendicular to the x-axis are squares. Our height or side length is y, and that's 3 minus x e to the minus x. We want to integrate area, which would be side squared, which would be 0 to 3, 0 to 3 of y squared, but that's 0 to 3 of 3 minus x e to the minus x. Don't forget to square that dx. Okay, I'll pull out my calculator and I'll integrate second entry. I'll integrate parentheses, 3 minus x, close parentheses, e to the negative x, close the parentheses on the e to the, close parentheses on the function so that we can square it, comma x, comma 0, comma 3. And I get 3.249. 3.249 is choice C. Let's move on. Okay, 32. 32, which the graph of the derivative is shown above. Which of the following could be f? Well, so when I look at this picture, I see f has 0 slopes at -4 and 4 and 0. So where do I have 0 slopes at -4, 0, and 4? That happens here. That does not happen here. That might happen here. That does not happen here. 0 slope there, no. So I'm down to B and C. Now, what else do I know? I have inflection points at -2 and +2. -2, I go from concave up to concave down. And an inflection point at 0. And I have an inflection point at 0. Don't I have that here as well? Oh, but look, this f prime is above the x-axis, so f must be increasing, so B is my answer to number 32. Okay, 33. 33 says, which of the following polynomials has the same as a to b of f of x dx? We're told that this is an even function. So think about an even function for a minute. What's true about an even function? F of x equals this x comma f of x, and over here negative x, f of negative x. So f of negative x equals f of x is what I know about even functions. Okay, so the integral from a to b of f of negative x. So they're saying the area from here to here would be the same as the area from here to here. And I believe that to be true. What's next? The absolute value. A to b, absolute value of the function. Well, but that's going to be the same for an even function, because an even function always folds across the y-axis. I guess even if I had something like this even function, and then did the absolute value, I'd still be looking at this picture, where this area and this area were the same amount of area. So I like the integral from a to b absolute f of x. And what about the last one? From negative a to negative b. From negative a, oh, oh, wow. Okay, I have to go back and say even function from a to b. Even function from, this is negative b, this is negative a. Okay, so I know that the integral from negative b to negative a of this function is going to be the same value as the integral from a to b. So I know that Roman numeral 3 is correct. Now, Roman numeral 1. So if I take this function and I do this transformation, f of negative x, that means I'm going to divide all the x's by negative 1. So this one's going to come over here, and this one's going to come over here, and this one's going to come over here, and this one's going to come over here. This is a reflection across the y-axis. And that's what an even function does. So Roman numeral 1 works. Now, the absolute value from a to b, that's a little different. Okay, so if I have this function, and I say the absolute value of this, oh, let's do this one. Here's an even function. So the integral from a to b, in this case, would be a negative number. But if I integrate the absolute value, then I'm going to get a positive number for that area. So those two are not the same. 2 does not work. So I want 1 and 3 only, and that's choice E. E for number 33. Okay, 34. 34. 34 says we've got this wacky function f shown above. Which of the statements is true? F of a exists. No. F of a is a big old hole. B, the limit as x approaches a of f equals 2. That's true. Should I go further? Well, just to be sure, the limit as x approaches b of f equals 1. Well, from one side the limit is 1, but not from the other side, so the limit at 1 does not exist. That does not exist. The limit as x approaches b from the negative side of f equals the limit as x approaches b from the positive side of f. Well, we just got through saying they're approaching two different y values, so no, those limits aren't the same either. And then f is continuous at 0. F is not continuous at 0 because the limit of the function doesn't equal the value of the point. So my answer here is B for number 34. 35. The rate at which bacteria is proportional, so d, b, d, t, is proportional to the number of bacteria present. At 2, there were 500. At 6, there were 1,500. Approximately how long does it take for the population to double? Okay, double. All right, so let's build this. We've got dB over B equals K dt. We integrate, we get ln of B equals KT plus C. We exponentiate, we get absolute B equals e to the C, e to the KT. We get B equals plus or minus e to the C, e to the KT. We'll say plus or minus e to the C equals A. And so B equals A e to the KT. Now we can plug in what we know. We know 500 equals A e to the 2K. And we can plug in what we know. 1500 equals A e to the 6K. So I've got a system of equations. I divide to eliminate the a's. I get 1/3 equals e to the minus, subtract the exponents, 2 minus 6, negative 4k. So I get ln of 1/3 divided by negative 4 equals our k value. Okay, so now we've got this model with a k value anyway. So we've got 500 equals A e to the 2 times ln of 1/3 over -4. Actually, I'm going to take out that point, and I'm going to say I want to double the original amount. So I divide both sides by a. I get 2 equals e to the ln of 1/3 over -4t. Ln of 2 times -4 over ln of 1/3 equals 2. Here, -4 ln of 2, close parentheses, divided by ln of 1/3. And I get 2.524. 2.524. 2.524 is choice A. Okay. Next, 36. 36. Graph of piecewise f is given on -4 to 4. Yes, it is. Consists of a line segment and a semicircle. Function defined g, -4 to x. What's the value of g of 4? So g of 4 would be the integral from -4 to 4 of f of t dt. So we need to integrate, and when I look at this graph, I see this is 2, this is -4. Up here we have a y value of 6. I've got a big old triangle to find the area of, and then they told me that this was a semicircle. And that's 3, and that's 4, so my radius is 1. Pi 1 squared is pi. Pi would be the whole circle, but I only have half a circle. And this half a circle is below the x-axis. So this is -pi over 2. Okay, so minus pi over 2. And then what about my my triangle? Well, it's got a height of 6 and a base of 6. 2 minus 4. Right minus left is 6. So 1/2 6 times 6, which is 18 minus pi over 2. 18 minus pi over 2 is choice C. C for number 36. 37. 37 says f prime equals 8 cosine x over x squared minus 1/8 on the open interval from 1 to 10. The graph has what? Well, let's take a look at this graph and see what it has. 8 cosine x divided by x squared on 0 to 1, no, on 1 to 10. And I'm going to go -1 to -2 graph. Okay, so this is my f prime sign chart. F prime, above, below, above, below. Is that what I'm seeing? I think that's what I'm seeing. So I've got a 0, a 0, and a 0. This is a max, this is a min, this is a max. So 2 max, oh, is that 1? Yes, that's 1. 2 max, 1 min, and these maxes and mins on f prime mean 2 inflection points on f. So what do we see? 1 relative max and no relative min? No, that's not true. 1 min, no max? That's not true. 2 max, 1 min. 2 max, 1 min, that's ours. 2 max, 1 min is choice C. Choice C. 38. 38 says Water drains from a tank. The rate in gallons per second is given by the table values above. What is the trapezoid approximation for the amount of water that drained from the tank in the first 10 seconds? Okay, so subinterval widths are not the same again. Why should I be surprised? 3 minus 0 times 16 plus 10 plus 8 minus 3 times 10 plus 6 plus 10 minus 8 times 6 plus 5. Okay, so that's 3 times 26 plus 5 times 16 plus 2 times 11. 60, 78 plus 80 plus 22. 150, 60, 70, 180 divided by 2 is 90. And 90 gallons is choice D. Choice D is 38. 39. I'd say get up, take a break, walk around a little bit, but we don't have time because we've only got 50 minutes to do all these problems. Equals t to the third over 3 plus 2t plus 2. For what values on the interval 0 to 3 will the instantaneous velocity of the particle be equal to the average velocity of the particle? Okay, so v of t. Oh, average velocity is the average rate of change in position with respect to time. So that's x of 3 minus x of 0 over 3 minus 0. And we want to know when the velocity, when v equals that. Okay, so let's find x of 3 minus x of 0. 27 divided by 3 is 9. 9 plus 6 is 15, plus 2 is 17. If I plug in a 0, I get 2 over 3 minus 0. So 15 over 3 is 5. I want to set the velocity function equal to 5. Velocity function, v of t, is going to be t squared plus 2. So I set t squared plus 2 equal to 5. T squared equals negative 3. It looks like that never happens, and yet it says it does happen. Ooh, I got a mistake somewhere. Did I copy the problem down wrong? I did not copy the problem down wrong. Instantaneous average, that's x of t, average velocity from 0 to 3. That's average rate of change, that's average velocity on 0 to 3. Let's plug this into my calculator and confirm that I got the correct values. We've got x to the third divided by 3 plus 2x plus 2. I go over to the table, I plug in 0, I plug in a 0, and I plug in a 3. Yes, 17 and 2. 17 minus 2 is 15. 15 divided by 3 is 5. I like that. Now, what's the derivative of this? I'm going to bring the 3 down. The 3's cancel. This becomes a 2. And I'm going to take the derivative of this, and I'm going to get 2. So that's my derivative. Oh, I can't subtract. So t equals square root of 3. That's where my mistake was. And that's choice B. Choice B for number 39. 40. 40 says f prime equals square root 1 plus x to the third. F of 1 equals 1 half. F of 4 equals what? Well, f of 4 minus f of 1 should equal the integral from 1 to 4 of square root of 1 plus x to the third dx. Please, God, do not try and do this by hand. Instead, just simply add f of 1 to both sides of the equation. F of 1 is 1 half, so 1 half plus the value of this integral. Let's get the value of this integral. Math. f int square root 1 plus x to the third, close, comma, x, comma, 1, comma, 4. Don't forget to add the 1/2. And so I get 13.371. 13.371 corresponds to choice D. Choice D for number 40. Okay, 41. 41 says, let f be twice differentiable function that when x equals c, f is decreasing, concave up, and has an x-intercept. Decreasing, concave up, and has an x-intercept. Okay, so f prime is less than 0. Concave up, f double prime is greater than 0, and f equals 0. So if I'm supposed to put these in order from greatest to least, or least to greatest, I'd have f prime was smaller than f was smaller than f double prime. And that's true for choice C. Choice C for number 41. 42. 42 says, let f be given by this wacky function x squared e to the negative x, for what value of x is the slope of the line tangent to that graph equal to 0.2. So I want to know when f prime equals 0.2. Okay, so let's do this. We've got x squared e to the minus x is our function. And I don't actually want to graph that. I want to graph n derivative of y1, comma, x, comma, x. And I want to graph the line 0.2. How about, and do we give it an interval? It looks like when I look at the values, they go from -1 to 5, -1 to 5, and we want to know 0.2, so 0 to 1 should be plenty. Okay, here's a graph, slowly graphing. I need to wait until I get the horizontal line at y equals 0.2 to show up. Oh, we only have 4 more problems. That's great. There's 0.2, so I do second, calculate, intersect. Enter, enter, enter. And it finds 1.418, and that's D. It looks like there's this other one over here, second, calculate, intersect. I'm a little curious about that, so I'm going to go over there and see about finding that value. And enter, enter, enter. And I get here 0.1199, so 0.120. 112. This is not 112. Oh, that's tricksy. Yeah, so that one's not there. D is, in fact, our answer. Wow, easy. Okay, the Riemann sum for number 43. Pi over n sigma I equal to 1 to n of sine of pi I over n is the integral of sine x dx from, this is b minus a over n, so we've got pi minus 0 over n, so 0 to pi. 0 to pi, sine x, that's choice A. Okay, 43 was A. 44. 44 says the region bounded by 4 minus y squared revolved, and the y-axis is revolved around the y-axis, so this region revolved around the y-axis. I don't want to do shells, but I think they want me to do disks. So my height is 2y, my radius is 4 minus y squared, 2 pi integral negative to the 2. No, these are dx's. Sorry. This is 4. 0 to 4 of 2y, 4 minus y squared, dy. No, ew. Oh, that's why. 2y. Radius is x. Wake up, Koopa. Okay, and y equals square root of 4 minus x times 2. Okay, so now, really, you probably should have done this with disks. Don't follow me down here. 0 to 4 of x to square root 4 minus x dx. Okay, so 2 pi math integrate 2x square root 4 minus x, comma, x, comma, 0, comma, 4. And I end up with thinking it's gonna do some thinking. Gotta do some thinking. 107.233, which is choice D. Choice D for number 44. And finally, 45. Radius of a spherical balloon is increasing at a constant rate. dr dt is 5 millimeters per second. The rate of increase in surface area of the balloon, dSA dt, is what we're looking for. We know that when the volume V equals 36 pi, that's 4/3 pi r cubed. So I get 27 pi equals pi r cubed, r equals 3. So when r equals 3 and dr dt equals 5, find dSA dt. So if I take the derivative of s, 4 pi r squared, I get ds dt equals 8 pi r dr dt. Don't forget to take the derivative of that side function with respect to time. We get 8 pi times 3 times 5. 40 times 3, 120 pi millimeters squared per second. I like choice D. And we're done. Okay. I hope this was helpful. Our first of 4 multiple choice packets. Feel free to ask questions.